This is lesson 6.5. We're solving problems using quadratic equations. So, the way we're going to solve some of these problems is to use consecutive numbers. So hopefully consecutive numbers are pretty clear, but basically they are numbers that have a difference of 1 between them, right? Every two numbers. So like 3 and 4, negative 11, negative 10. Those are consecutive numbers. 8 and 9, right? Any two numbers that have one number between them. Okay, so the example says find two consecutive integers whose product is 56. So these two numbers need to multiply to each other to give you 56. So you might do that in your head and say, well, it's probably 7 and 8 because 7 and 8 multiplied gives you 56. The product is 56. Well, unfortunately, we need to show how we can find out those two numbers. All right, so the way we do that is we have this what's called a let statement. Okay, you're going to need to have a let statement, an equation, a solution to the equation. You'll check for the problem suitability, and then finally you'll have an answer in sentence form. All right, so we use this statement called let. We're going to say let n, which is representing a number, right? That's going to equal the first integer. And then our second integer, we know will have to be different by 1, right? So we could either say n plus 1 or n minus 1, but it has to be different by 1. So we're going to keep it simple here, not worry about the negative. We're going to say n plus 1 is our second integer. Okay? So now we know the product is when you multiply those two integers. So we have n times n plus 1 has to give you 56. Any questions up to here? Anybody lost so far? We're looking for two numbers. There's a difference in those numbers of 1, and they multiply to give you 56. Pretty simple so far, I hope. That's how we get to here, okay? Once we get to here, believe it or not, the hard work is done. You guys should have the necessary skills and practice now to go from here to do the rest of the way. Really, setting up the question is the hard part. That's set up. What do we do next? Now we're going to expand out and we're going to factor. So we multiply n times n, we get n squared plus n equals 56. Now we put all the terms to the left. N squared plus n minus 56 is equal to 0. We factor this term. Now you can use straight product and sum rule. Okay, what two numbers multiply to negative 56 and add to give you positive 1. Or you can use your crisscross method. Either way, you should come up with the numbers positive 8 and negative 7, right? Because they multiply to negative 56, but add to give you positive 1. Okay, so that is our factored form. This, hopefully, after all that factoring you guys did for your bonus marks, which most of you did, is a pretty easy factor. Okay, so now we have this. Now, I've gone over this in extensive detail, but this results in two equations, right? N plus 8 equals 0 and n minus 7 equals 0. Why is that? Because anything times 0 equals 0. So if either of those two cases are true, the full equation is true. Does that make sense? I hope so. So now we say n plus 8 is equal to 0 and n minus 7 is equal to 0. Those are the two conditions that we need to solve for n. We get n is equal to negative 8 and n is equal to positive 7. So that's our answer, right? These are the two numbers that multiply to give you negative 56 that are only, they are consecutive because they are not consecutive. They're not separated by 1. Okay, so we need to come up with n minus 1 or n plus 1 in this case. So we see here n is equal to negative 8. Sub that in for n. We get my resulting number as negative 7. Now this is a little confusing because we have, you know, the negative 7 here and the 7 here, but you really have to treat these as two separate answers, right? We have the n plus 8 is equal to 0. This is one full answer. So our two numbers are negative 8 and negative 7 when I sub into my variables at the beginning. And the full second answer is n equals 7, and my n plus 1 value then is 8. All right? So based on those two answers, the two consecutive integers are either negative 8 and negative 7 from the first example, or positive 7 and positive 8 from the second case. Right? Now if we check, we multiply them out, we see we get 56 and 56. Any questions? All right. That's the first example. The next example, we're talking about consecutive even or odd numbers. Okay? Consecutive even or odd numbers that follow each other in order. So they have a difference of 2 between them. So the examples would be like 4 and 6, right? Those are both even numbers and they have a difference of 2 between them. Okay? And odd consecutive numbers would be like 7 and 9. Does that make sense? Or 5 and 7? You guys understand that? You have to get the idea of what consecutive numbers are before you can even start this problem. That's really the hard part, is just developing this formula. So then if we know that they're 2 numbers apart, we can say let the first number be the first odd integer, let's call it x, and the second one is going to be the second odd integer, x plus 2. We're adding 2, right? When we go through odd numbers, 3, 5, 7, 9, 11, you're always adding 2 to get your odd numbers. All right? So if these are our 2 numbers, it says they have a difference of 2. Find 2 consecutive odd integers such that the square of the first added to 3 times the second is 24. So if I've decided that x is my first integer and x plus 2 is my second, I'm going to do the square of the first, x squared, plus 3 times the square of the second, 3 times x plus 2. So 3 times the second is equal to 24. Any questions up to here? How that was developed. That's the hard part. Once you got there, the rest should be pretty simple. We're dealing with relatively small numbers here. You should be comfortable in factoring this. First thing we're going to do is combine the 24 with the 6 after we've expanded, right? We get negative 18. Then we're going to factor this so we have x plus 6 and x minus 3, right? You need 2 numbers that multiply to negative 18 but add to positive 3. That's positive 6 and negative 3. Okay? So we factor this now. That's all equal to 0. Now we have 2 cases once again. And we know why we have 2 cases, because anything times 0 is 0. So if this is true, if that's 0, this whole thing is true. If this is 0, this whole thing is true. So therefore, we need to consider both of these cases. So when I solve for x plus 6 is equal to 0, I get x equals negative 6. Now, why is this not possible? Why is it not possible? Let's go back to the original question. What's it's asking? Find 2 consecutive odd integers. Why is this not possible? Yeah, because it's even. It's not an odd integer. It's an even integer. So that's what this is meant, where it says here, check for problem suitability. Right here, underline, check for problem suitability. You have to make sure that this answer makes sense with the original question. Because it says odd, this no longer makes sense, negative 6. So we only have one option, x equals 3. Is it odd? Yes, it is. Okay, now I need to find that second number, so I'm going to go back to my original declaration. X plus 2 is my second integer, so I'm going to add 3 plus 2, and I'm going to get 5. So therefore, my 2 consecutive numbers are 3 and 5. Yeah?
How'd you get x plus 6 and x minus 3 in brackets?
I factored from here to here. So 2 numbers that multiply to negative 18 that add to give you positive 3.
Yeah.
You remember that, right?
Yeah.
How to factor? You did like how many questions on it? Yeah?
How do you get 5?
How did I get 5? I went back to here. The second number is x plus 2 that I declared at the beginning. So if my first odd integer is 3, that's x. 3 plus 2 is 5. Got it? Any questions? All right, hopefully those 2 are pretty simple. They get a little bit harder now. This one is substantially harder. All right. A rectangular field will be fenced on all 4 sides. So this is like finally a question that you might actually use in like real life. So let's say you are you work for a Pee-wee soccer league and you're setting up a field and they give you a bunch of rope and they say, give me the largest field you can with this rope. This is something you could actually use these equations for. Believe it or not, this is something that you could do.
Okay, but I could also just divide it by 4 and then stretch it out.
No, you can't because of this. Because he wants a barrier in the middle. Yeah. You're close, but yeah, they added that to make it a little trickier. So he wants a rectangular field fenced on all 4 sides. Okay? There'll also be a line of fence across the field, parallel to the shorter side. Okay? So this is the drawing that I've come up with. So it's rectangular. It's got 4 sides fenced in. We've decided to use X for the width. Could have used W here, but we use X. And then we've used L for the length. Okay, so this drawing, hopefully, from this description, you can create this drawing. If you can't solve the problem. You're going to be stuck. So the only thing I can suggest to you of how to teach this to you or to make you figure this out is practice. You got to practice, practice, practice. You got to see these problems over and over again, and then you will recognize how to draw this rectangle from this description. But if you don't practice, if you don't do your homework, it's going to be extremely difficult to just try to come up with these drawings. So it says, if 900 meters of fencing are available, what dimensions of the field will produce the maximum area? And what is the maximum area? Okay, so what dimensions of this to get a maximum area using my length of 900 meters? All right, so the 900 meters is what? The perimeter or the area of this particular rectangle? What do you guys think? Yeah, it's the perimeter, right? It's asking you for the area. So therefore, the rope that we're using to create this field is basically the perimeter plus this piece, right? Because that's an extra piece. So we can say 900, that's our total rope, is going to be equal to all of these sections of rope. So we have 2 L's, 1, 2, and we have 3 X's, 1, 2, and 3. Does that make sense? 900, why it's equal to 2L plus 3X. Anybody confused here? You guys understand this? Why this is equal to this? That's the hard part. That is, believe it or not, the hard part. The rest is just math. It's just math. Should be the easier part, in my opinion anyways. Trying to get that right equation is the hard part. Okay, so now if I rearrange this to solve for L, I'm isolating L by itself. I bring the 900, I bring the negative 3x over, this 3x over, and then I divide by 2, so I get L by itself. The reason I do that is because I want to plug in to the area formula, and you have to have this memorized, right? You have to know that the area of a rectangle is length times width. In this case, we've used X as our width, so it says here let X equal width. Could have just started with W's, to be honest. Would have probably been better. So our area formula then becomes all of this, which we've determined is L down here, times X. Any questions on the area formula? It's clear, right? Okay, so now we need to solve this equation. We're going to expand, so X is going to multiply by the 900, X is going to multiply by the negative 3X, and all of that is going to stay over 2. So we get 900X minus 3X squared over 2. Now if I divide the 400 by 2, or sorry, the 900 by 2, I get 450, and if I divide the 3 by 2, I get 1.5. So I'm left with this expression for my area. Now I would have liked this the other way around, just because we're used to seeing the x squared term first. Okay? In any event here now, what we need to do to solve, to find out x, which is the width, is we need to factor. So what do we have in common between these two terms? X. So we're going to divide out x. So we're left with 450x divided by x is 450. 1.5x squared divided by x is 1.5x. Negative. right? So we have this expression. Now with this expression, if x is equal to 0, this whole thing is true. So x equals 0 is one of the options. Okay? Now we need to think about that. Can we have a width of 0? No, we can't. So this option doesn't work for us from the suitability of the question. That's going to happen a lot when you have questions that involve time, where time is negative. Doesn't work. So here we have x equals 0. We're not considering that one. We need to evaluate this 450 minus 1.5x. Set it equal to 0. Why do we set it equal to 0? Anybody know why? Like, why are we setting the area equal to 0? Anybody know why?
Are you trying to find something else?
Okay, well, let's take a look at this graph here. Okay. We know, based on this having a negative a value, that this is a parabola that opens down. Okay, Adrian?
You're trying to find x, y, and 0.
Sorry?
You're trying to find x.
I'm trying to find the... Actually, what I'm trying to find is the vertex, right? The y value of the vertex. So the way we do that is we first find the x values. Okay, 0 and 150. Sorry, 0 and 300. And then if we find those two values, we can split it in half. And then we know that's the x value of the vertex. And then we can sub that in and get the y value of the vertex, which is the answer we're looking for. That is why we're setting the area equal to 0 so we can find the zeros. The x-intercepts. Once we find the x-intercepts, which we do here, we find them to be 0. Sorry, I shouldn't have crossed this out. Because it's valuable for us because we need those two values, x equals 300 and x equals 0. Those are the two that we need. When we add them and divide by 2, we get x equals 150. And then if we have x equals 150, we know that is the x value of the vertex. We can sub that in, 150, 4x, into the original equation, which is here. And we get our max area, which is 3,375. No, 3,350 meters, right? This is all in meters. Okay, we could have also gotten this x value without getting the zeros. What could have we done from here? Anybody know? Andrew knows this. The x value of the vertex is what? Minus b divided by 2a. So if we would have done that right from here, what's b in this case? Sorry? Yeah, b is 450, even though it's out of order here, but it's negative 450 over 2 times a is what? Not 1.5, but negative 1.5, right? So we have negative 450 divided by negative 3. What's that? 150. There you go. You could have used that nifty little shortcut there. Without factoring, you would have got the x value of the vertex. We've seen that a lot now, right? Yeah, Lucas. Say it again. Because I had x equals 300 and 0. Those were the zeros on the parabola. If I add them and divide by 2, I get the middle point. Right? You got it? That was over here. See, Lucas? That's 150 right there. Any other questions with that one? I wouldn't say that was an easy question. That was a tough one. Example 4. Paul is creating dog runs for his dog kennel. He can afford 30 meters of chain link. So very similar question here. To surround 4 dog runs, the runs will be attached to a wall. To achieve the maximum area, what dimensions should Paul use for each run and for the combined enclosures? So in this case, is there chain fence here? That's an important question, right where I'm highlighting. You guys tell me. Am I using chain to create that? Stefan, what do you think? 50-50 shot. Yeah, you're right. We're not, right? Because he said it's against a wall here. So the only area that he needs to chain is this dark line here, this. Do you guys understand this? This length is the wall, so there's no chain there, okay? He has a total amount of chain of 30 meters. So, and he wants to create 4 dog runs. So you can see you have to draw this out before you can make sense of this. Okay, oh, you have a picture over here, so it kind of helps you a little bit. So this is, they want to create a maximum area, so you might know that maximum area of a rectangle is a square. You might know that, okay? But you don't need to know that to figure this out. You just need to be able to label this properly. So we have 4 spaces here. We know the width out is x. We're letting that be x, okay? And we're trying to determine here the length, right? This length is an unknown, okay? So we have 30 has to be 5 x's plus L, right? 30 is our total chain. So this, and this, plus this has to equal 30. Does this equation make sense? Or does anybody have any questions about that equation? Yeah, Alan. The 5x is from these 5 lines. 1, 2, 3, 4, 5. Okay? And we decided they're called x. You could have called them w, could have called them whatever. So then if we know that that is our total chain length, 30, we can rearrange this and we have a formula for the length in terms of x. Okay? Now, once we have that formula, we can plug it into our area calculation. We know our area is going to be length times width for a rectangle. We've determined that the width is x here and the length is 30 minus 5x, which we've determined here. So we're trying to get this total maximum area here. Okay? So we rearrange that equation now. We multiply this to expand it. We get negative 5x squared and 30x, right? Multiply this times this. Again, I would have probably wrote it like this. Okay? And here you can see we've decided to use the shortcut to find the x value of the vertex, negative b over 2a. We know b is 30, so it becomes negative 30 over negative, should be negative 2a. Oh, sorry, 5, yeah. 5 is a, so negative 2 times 5 is 10. 5 times 2 is 10. 2a. And so we have 30 divided by 10 is 3. So our x value of the vertex is 3. This was a much faster way than trying to factor this, then adding them and dividing by 2. It was much faster, right? Once we have our x value of the vertex, we plug that into our formula here, and we find the y value of the vertex, which is 45. So therefore, the max area is 45 meters squared. Go back to the question for the units. We can see it's in 30 meters. You need to know that we are then dealing with 45 meters squared for area. Okay, here we go. Max area is 45. Width to achieve the max area. So we need to solve for the width now. Oh, sorry, we have the width. X is equal to 3. We did solve that. Okay, 3 and 45. And finally, your length is equal to 30 minus 5 times the width, which was determined over here, right? This is your length formula over here. We determined that we have a length of 15. That's your total length here. To get the individual length for each of the bins, you would divide that length by 4, because there's 4 sections to it. 1, 2, 3, 4. And then if you do that, you get 3.75. So we know each one of these dog bins is going to be 3.75 meters times 3. So almost squares, but not quite. Any questions? All right, moving right along. Last one, and then we'll do the quiz. Tickets to a school dance. Here's another example of how we may be able to use these equations. We have school dances here at our school. They cost $4. Ours are quite a bit more. And the projected attendance is 300 people. So for every 10-cent increase in ticket price, the dance committee projects that attendance will decrease by 5. So it makes sense, right? They charge more money, less people are going to want to come. Charge less money, more people are going to want to come. So they've determined that if they charge $4.10, they're going to have 295 people, right? Like 5 less people, okay? So it says, determine the dance committee's greatest possible revenue. Any idea, without looking at this, how to do this problem? Who has an idea? Because that's where it all starts. If you're just sitting there blank, no idea where to start, it's going to be very difficult exam. Let's put it that way. It's going to be a very difficult exam. We have a written exam as you guys requested. This is going to be very likely one of the questions.
You did take a vote for that.
Where did we start? We did take it. We did. Who wants to? Yeah, Andrew.
So we have to write it out.
Yeah. So what would you do? Just give me like a general plan, okay? So we say it says determine the dance committee's greatest possible revenue. So how would revenue be determined?
Tickets sold and the price.
Yeah, number of tickets sold times the price, right? And so what would be your general idea of how to find that maximum revenue?
So like after max revenue equals
Tickets times,
people, like people.
yeah, the cost times the people. But I'm just trying to get an idea, like, based on everything we've learned, we know we're going to have some sort of quadratic equation, right? We very likely know it's going to be opening down, right? So what's the idea here? Look here. Sorry? Yes, we need to find the vertex of this parabola, right?
Yeah.
So the parabola is going to be made up of revenue is the y-axis, and what is the x-axis? Yeah, people, number of tickets sold, right? So if we can find out when the revenue is 0, let's say, then we could take those two zeros, we could divide by 2. Sorry, we can add them and divide by 2. We'll get the middle point. That should be the height of the parabola, right? And that will give us max revenue. So that's the general idea, right? So how do we do that? The first thing we need to do is establish some variables, right? So here we go. We say R is the revenue. It's the number of people times the price per ticket. And then we say let X represent the number of 10-cent increases. So this is important now. Because we have this happening every 10-cent increase, we lose 5 people. So if X represents the number of 10-cent increases, we can say that the revenue is the number of people, which we know is going to go down by 5 for every 10-cent increase. So what we need to do with the number of people is we need to subtract 5 times the number of 10-cent increases, in this case, which is X. And then the price per ticket we know is going to go up 10 cents every time we have a 10-cent increase. So the price per ticket would be $4 plus 10 cents times X, the number of increases. All right? So this right here, in my opinion, is the hard part. Just coming up with those two numbers. And how do I teach that to you? It's tough because every problem is different and it's a lot of logic. The only way I can say that you'll really sort of get good at it is to practice. It's like anything else. Right? I can show you each example, but unless you practice it yourself and get in the habit of trying to create these formulas, it's not just going to come to you. It does take time. So we have our formula here for revenue, and it says here we're going to find the vertex to get the max revenue. So we're going to expand our formula here into standard form here. So we say 300 times 4 is 1200, 300 times 0.1 is 30, x, and then 300 times 4 is, sorry, 300, negative 5 times 4 is negative 20 x, and then negative 5 times 0.1 is negative 0.5x squared, right? These x's. So we have this, we rearrange it, we reorder it, so it looks like this. We have it in that form. We know then our a value is negative 0.5. We know our b value is 10, and our c value is 1200. We'll use our nifty formula, negative b over 2a, to get the x value of our vertex, which turns out to be 10. We sub that back into our original formula up here, and we get our y value of our vertex, which is our maximum revenue, $1,250. Okay, so after we did the original equations, it was relatively simple and straightforward to find the max revenue. Okay, so that's the answer to A. What's the answer to B? What is the ticket price? What ticket price will produce the greatest revenue? We found it, right? It was here. X. Oh, sorry. X was 10. That's the number of 10-cent increases. So what's the ticket price? We're going to 10-cent increase 10 times. Right? So how much are we increasing the ticket price by? $1, right? So it would have been 4 plus 10x, right? Because that's our increases. Sorry, 10 is x, 0. Let's try this again. This is our ticket price. It's $4 plus 10 cents times the number of increases. Now we know x is 10 for the max revenue, so it's 4 plus 0.1 times 10. So we get 4 plus 1 equals 5. So there, our ticket price with the greatest revenue would be $5. Produces greatest revenue. All right, this question is very similar to the one above. I'm going to stop there to give you more time on your quiz. So we will continue here. This is very similar to this one above. You should try to do this one on your own. If you are not able to complete it, please ask me tomorrow. We can review it.